if you ever wonder why the VRM temperatures are not stable, they're constantly going up and down, even though you have a monoblock, EK monoblock that covers the processor in the VRM section, I discovered a small little error there. When I put the original shroud back to figure out what was going on, it turns out to be that the original shroud was covering the VRM from one section here to all the way to the end, covering the whole entire thing. When I took that off and put the EK block on it, I realized that it was only covering from one end to this end here, leaving out 3 or 2 uncovered, and the thermal paste sticking out. So I contacted EK and I asked them that, and they said that's the way the design was made, that was sent by Asus to them. When I contacted Asus and asked them the question about that, they said if you look at the original shroud, it actually covers from one end to another end. If you have the EK block, you might want to contact them and figure out how to fix that, or if they have a new design block. Well, I didn't have the time to do all that, and I needed to resolve the problem because my temperature for the VRM was constantly fluctuating up and down between 47 to 67, 57, whether I'm overclocking or not overclocking. Even at standing on idle, it was like, and there was time that the motherboard will, I guess from overheating in that section, or maybe 2 of the VRM were not covered, was causing the motherboard to restart automatically by itself. I thought I had a memory issue with that, or an unstable clock. It turns out to be that that was not the case. Anyway, I found a solution and I found the problem. So I am going to show you what I did and how to resolve that and fix that, and get everything on the VRM section stable with the temperature. This is a little project, and with no further ado, let me show you what I did. So if you have this board, you probably want to do this and check your VRM temperatures, because if you're overclocking, this could be a serious problem. And according to Asus, they said that if the VRMs, all the VRMs, if they're not covered like the way they are covered in the original shroud, that yes, it can cause an unstable clock, even if 2 or 3 of them are not covered and they're not protected. So, no further ado, let me show you what I did. So here's the Encore X299 with the EK monoblock on it. As you can see, their design go from this end to this end here, and then the problem that I discovered is, get as close as I can to the camera to get this. As you can see here, it's out of focus. I'm trying to get this a little closer to you guys so you guys can see it. I don't know if I could get this. I'm gonna leave this marker here so you can see what I'm talking about. And I don't know if you can see it, but there's a section here where the 2 VRMs, I think 3 of them are not, this section of the block of the EK is not coming all the way to the end where it's supposed to cover those 2 extra VRMs there. And that's the problem there, that it's overheating. So let's see if we can get a closer shot of what we're talking about. So see if you can see it. So I'm gonna pan down a little bit and see if we can actually focus onto that area and get a little closer, right there. Yeah, so if you could see where I have my marking at, which is this section here, it's not covered. So this is what I came up with. I cut this out on my CNC machine, and this is a small heatsink that's actually going to come over and line up in here and get those 2 VRM completely covered. And I cut it exactly that it will fit, and it doesn't touch the capacitor and the extra chip that's there, and any of the chips that are under the VRM. So it's actually, the way I designed it, and cut it out. It's actually covering completely there, and that's all I have to do. So I came up with this little small piece of wood that's gonna go under this, and we're gonna line it up in here, and it will screw on to this screw that I came up with, this guy here, and we're gonna screw this all the way down until it passes through, so that we can make contact to on the case screw and then screw down. If you do design this and make this, one thing, do not put too much pressure to tighten this up too tight, because and then what's gonna happen is if you tighten it up too tight, it's just gonna it's gonna lift. This section is gonna come up off the VRM. So just a hand tight, not too tight, and that should do it. When I did this and I put the motherboard back into the case and run hardware monitor, I saw my temperature drop by an additional between 10 to 20% down. So when I turn it on at idle, it's showing 31, 32 Celsius in that section. That's what I overclock. And as soon as I overclock to I think it was 4.9 on this 18 core 10980, and I started playing games, the temperature for the VRM, the maximum actually went up to about 46, and it was gradually going up and down, 44, 46 in that range. Before that, and that I didn't have this little heatsink in there with the thermal paste on it, the temperature, for some reason, even though I'm not sure if it's recording all of them at the same time or reporting the temperature, but it was reporting a temperature of 67, going from 67 to 55 to 45, then back up again, up and down while I was gaming. I was keeping an eye on this with the hardware monitor, and I was saying, well, there's something funny going on. Either the monoblock here section was not actually making contact whatsoever, and it turns out to be that was not the problem, because as I looked in the when I put the block in, it's actually smudging the whole entire VRM. You can see the thermal paste sticking out. So it's seated there correctly. And when I asked the zoo, they said that if 2 of them are not covered or 3 of them are not covered, it will make a difference when you're trying to overclock or trying to get several voltages across the processor and all that. So they said the original shroud that comes with it actually covers that whole section there. And they was telling me, hey, put it back or come up with a design, come up with something that you could get those 2 areas protected. So I did. On my CNC machine, I came up with this little piece I designed. I ordered 2 tiny heat sinks. That's gonna go on the surface here. It's gonna stick out about 1/4 of an inch high with little fins on them. These little small heat sinks are designed for little chips on boards or memory. Back then, remember how memory cards you had to put these little heat sink on the back of the memory of the video card. I ordered 2 of those. I will use JP Well glue, just a little bit mix, let it sit for 24 hours because it is heat passive, that glue, so the heat will actually pass through and allow it to cool down. You don't need to put a fan, because once this attaches here, it will make contact, the screw will make contact with the surface of the screw. Is also made out of aluminum, and once it's screwed down, it will make contact to the motherboard, passing the heat down to the back of the case, which is, that the case is actually made out of aluminum, not steel. That actually works. My temperature was sitting, even at overclock, it was sitting, the maximum I got was like 41, 42 in that range, even at 4.9 overclock on an 18 core. And I saw it much stable. It was no longer rebooting. It was not shutting down anymore. I thought it was the memory that maybe I needed to apply more voltage to the memory or apply more voltage to the processor. It turns out to be that was not the case. I lowered my voltage to the processor to eliminate a lot of the heat from the processor and stabilize my memory, and I went straight 12 hours playing Battlefield for 12 hours. I was online and I was keeping an eye on the temperature, and it was not even passing 47. It was between 47, like I said, 44, 46, 47, in that range. And I had a thermal reader, a temperature thermal reader, and I was reading this whole section, and it was showing 44, 45, even though the software hardware was reporting 2% higher. But with the thermal tester that I was looking at this area and the temperature in this area, it was actually giving a reading of 44 max. It was not even jumping. It was jumping between 41, 42, 43, like that. It was constantly at the times when I was playing the game and it was heavy low. I noticed it was going 44, 43 back and forth, but it never passed that. It never passed 44 or 45. Um, Without this idea of putting this in here, I was passing temperatures into the 60s, and it just didn't make any sense. So, like again, when I spoke to Asus, it says if the VRM, if two of the VRMs are not covered or certain of the VRMs, the block is not sitting correctly, you're gonna get unstable voltage, unstable temperature. Um, when I sent them a photograph of what I was doing, they said that would do it. Unfortunately, that was a design that they sent to EK, and EK made the block like that. I don't think they're gonna do any future upgrade on this block to extend it out further out here or what. But yeah, if this information helped you out, if you have an Encore X299 like I do, or iOmega, think about it. You might want to do this to prevent your temperature from going up so high when you're not doing anything. If this information was helpful, give a thumbs up, and not give a thumbs down. Subscribe to my channels, and I'll give you more, come up with more ideas of anything that pops up on motherboards and or video cards that could resolve problems from overheating and so on. Thank you very much, and good night. Hi, this is a quick add-on to the video what I just made. Make sure that the washer that you're using that is trimmed around completely, so that when you actually put it into the motherboard and you turn it, that it doesn't touch any of the chips that are nearby, any of those capacitors, so that you could turn smoothly without colliding to any of them and then have them pop off the motherboard, because they'd be very difficult to put back. That's very important. That's what you need to do. Be careful when you make this washer. And also, um, if you'd like to know the dimensions of this, give me a second, I'll give it to you. So the aluminum that I'm using, the thickness, it's 1.36 millimeters thickness. Uh, the length of it that I cut out was approximately 33.76 millimeters. Um, the in the width, we'll come down and see what this gives us. 11.60 millimeters. Where the capacitor and the second chip is at in the center, that's 10.34 millimeters. Where the capacitor is at, that's 9.63 millimeters. From an angle corner to the angle where it actually meets here, we'll measure that, and that one, that's 18.10 millimeters. From the screw where it meets to the motherboard in the corner, that one would be 12.3, I'm sorry, 12.83 millimeters. Again, this is an aluminum that I'm using that will help act like a heatsink temporary until I get the two small heatsinks that has pins on it that are used for memory chips to put on here. Glue it down with some JP well, which is heat passive. Once it's all that set, it will be done. Again, sorry for not adding this part on, but that's what you need to do. Be careful when you put the screw on, and make sure it's completely trimmed out, so that it doesn't touch any of the capacitors and all that, and pop them off the board, because trust me, it'll be very hard to put those back on. And then you have to RMA the board, and they know that you pop those off, and they won't honor your warranty. So again, be very extremely careful when you're making this. The thickness of the piece of wood that I'm using, which is actually let's see, it's 0.65 millimeter thick, and the size of it's 6.36 millimeters, completely going around. So you probably were saying, well, why don't you just use a plastic washer and all that? Because I tried to get a couple of washers, plastic washers, that to that dimension, that thickness, and I couldn't find anything. So the best thing was to use bamboo wood here, which is pretty good, and it will actually, I was able to get the sides of the screw, screw it in, and then actually turn it into a nut, so that these two guys would join here like this together, and will seat it correctly. When you put it onto the motherboard, um, start with the center screw on the motherboard, and then work your way up here, and kindly, gently, carefully, get it to screw on, and then go down. Don't make it too tight, because if you make it too tight, you're gonna end up lifting the heatsink here is gonna lift a little bit. You don't want that to lift at all. You want it to be nice and snug, but not too tight. Okay. Just a reminder again, make sure that you trim this pretty well so that it doesn't touch any of the capacitors or you pop them off. Okay, good night.